right, this is lesson 2-2, the distributive property in pre-algebra. Homework tonight is page 72, 1 through 26 odd, and 29 through 40 all. Do not skip that part. Make sure you are doing 29 through 40 all. All right. So, the distributive property. This is the single most property that we use throughout mathematics. Actually, we use a lot of the properties all the time. But this one, you can't get through algebra without it. We use it in pre-algebra all the time. So to distribute means to pass out. How do I know it's the distributive property? Because it's two numbers in a parenthesis, two or more numbers in a parenthesis separated by plus or minus signs. So we distribute over a plus or a minus sign, over addition or subtraction. So what this means is, when the A is next to the parenthesis, that means multiplication. Next to something means multiplication. So A is being multiplied by everything inside the parenthesis. So that's A times B plus A times C. I do A times B times A times C, and you can see I wrote them over here. Okay? With letters, I could have written it like this. Okay? Oh, excuse me. All right, so when I'm distributing, if I have, let's say I have it over subtraction sign. It's A times B minus A times C. Now, what about here? Is this distributing? No. These are different terms. Okay? This is all one term because it's not separated by a plus or a minus sign. So in this case, when you've got A times B times C, that's just being multiplied. It would be A times B times C. I don't do it twice. It's not over a plus or minus sign. Is that clear? Is that clear? All right, so let's look at what happens when I have numbers. If I just have numbers. Yes.
So then you would do 3 times 4 plus 3 times 1.
Exactly. And this is going to be probably part of your homework. We can do this in two ways, and both ways will be accurate. But tonight I want you doing this distributing. I don't want you to use your order of operations. 4 plus 5 is what? 9. So if I'm using order of operations, that's 9. I do inside the group. Okay. And that equals 27. But if I do use the distributive property, I'm doing like Jasmine said, 3 times 4 plus 3 times 5. I'm multiplying it by everything inside the parentheses. And that makes 12 plus 15, which is 27. See, there's more than one way to get there. Generally, we use the distributive property when there are variables involved. We use order of operations when there are numbers. But tonight, I want you using the distributive property because we're practicing that. Both ways will work. Why use the distributive property? We generally use it when we have variables, like I just said, because I don't know the value of x. So I'm doing 3 times an unknown amount plus 3 times 2. It's 3 times everything in there. And what does that end up being? What does that simplify to? What's 3 times x? Ryan?
3x.
Good. And 3 times 2? 6. Okay. Now, these do that we stop there. You must stop there. I don't add 3 and 6 together. Is that clear? You're done. Just pass out the 3 to everything in the parentheses. You are done. Now, let me talk about, really quick, the value of an X. This is an X tile. Okay? What that meant, 3x plus 6 means I have 3 of these x's plus 6 little dots. 1, 2, 3, 4, 5, 6. Now, if I were a kindergarten, would I ever put them in the same pile? No, because you know these are different objects. One are sticks and the others are buttons. A kindergartner is not going to put them all into the same pile. So we keep our variable terms different from our numerical term. A variable term can have a number and a variable, and a numerical term has just a number. You don't mix them. So you stop at 3x plus 6. That's your final answer. It's not, you haven't solved it, you're just simplifying it. All right, so let's practice this. Number 1, what's that going to look like? Pedro.
5 times x plus 3.
You're not completely passing it out. When you distribute, you have to distribute to everything in there. 5 times x is correct.
And x plus 3.
No. What does this mean? The parenthesis next to the number 5.
Multiply.
Means to multiply 5 times everything in there. So this part is correct. 5 times x. Plus, what are you missing? Don't you have to pass this out to the 3? 5 times 3. And what does the first one simplify to?
First, 5 times x. 5.
5 times x is 5 x's. That means I have 1, 2, 3, 4, 5 of those. And 5 times 3 is 15. That means I have 15 little buttons. Do you understand? We got to leave it like that. That's your answer. Okay, you guys try number 2. Go. All right, now check your work. 5 times x is 5x, plus 5 times 3 is 15. And we end up with 5x plus 15. Now remember, don't add those together because that means we have 1, 2, 3, 4, 5 plus 15 little buttons. 3, 4, 5, 1, 2, 3, 4, 5. So I have 5 x's plus 15 buttons. So remember, they're different kinds of tiles. Don't mix them together. 5x plus 15 is our final answer. Next, pause the recording and finish 2 through 6. Now, check your work. So in number 2, what are we doing? Let me go with Ashley.
We are doing 6 times y.
Okay, and
6 times 7.
plus 6 times positive 7.
Oh, 6 times
Plus 6 times 7. Good. And what does that simplify to, Ashley?
6 times y plus 42.
Right, and we don't have to say times. If you just do 6y, that means 6 times y. And do I keep going? Do I add 6 and 42? No, we stop there. That's as simplified as it can get. Next one, Jeanette.
Okay, so I first multiply 3 times m and 3 times 8.
What kind of 8?
Negative 8.
Good. Now put that negative in the middle.
And
What do you get? How would I guess? 3 times m is
3 times 8 is 24. 3 times m is 3m, and 3 times 8 is 24.
and so the final answer will be
3m minus 24.
3m minus 24. Perfect. Okay, next one, number 4, please. Let me see, Donovan.
Okay, so you do 4 times 3 minus 5 times y.
4 times y. Times minus y.
Sorry.
Okay? Minus 4 times y. Good. And what does that simplify to?
I'm still trying to get that last part.
Okay, so what's 4 times 3?
4 times 3 is 12.
And 4 times y?
This is 4y.
Perfect. So it's 12 minus 4y. So try the next one, Donovan.
Okay.
What do I do first?
Okay, first you do 10 times x plus 10 times 7.
Okay.
And that equals to 10x plus 70.
Perfect. Xander.
Yeah.
Next one.
Get it?
So I did 4 times k minus 2 times 4. I mean 4 times 2.
And what is that?
So I got 4k minus 8.
Perfect. Questions? Questions? Angela? Okay. So our distributive property is like saying this. I have 5 times 2 suckers per bag plus 3 Tootsies per bag. I'm making party gifts for my son's birthday party. So I have 2 suckers and 3 Tootsie Rolls per bag. But how many bags do I need? 5. Okay? So that's the same thing as 5 times 2 suckers plus 5 times 3 Tootsies. All together, I'm going to have how many suckers?
10.
And how many plus?
15.
Do you see why I can't add the 10 and the 15 together? Because they're different things. I've got suckers and Tootsie Rolls. I cannot add those together. In algebra, instead of using pictures, we use variables. So instead of a sucker, what variable can we use?
X.
Okay, instead of Tootsie Rolls, what? T. Now we're going to do the same thing. 5 times 2 suckers is 10 suckers. And 5 times 3 Tootsies is?
15 Tootsies.
Now, can I put that 10S and that 15T together? Can I make that 25? No, because it's 10 suckers and 15 Tootsies. Questions? All right, so let's try this. Let's go. You do number 1 through 6. Pause the recording and then check your work. Reminder. All right, so on number 1, what am I doing, Tatiana? Is it? Oh, Tanya, sorry.
You're supposed to put 4 and x equal 4x.
Okay, 4 times x makes 4x.
And then you multiply 4 times 7.
Is
28.
what kind of 28 minus 28? 28. Good. But we're not doing double negatives. So if you put it in the middle, that negative for the 7 is just moved over a little bit. All right, now, this one right here is a little bit tricky. So y times y. Okay, who wants to do this? Okay, Angela?
Okay, well, first what I did was I distributed it, so I did y times y,
Good.
and then I did plus y times 3.
Good.
And so
Now wait, hold on. So y times y plus 3 times y. We always write the number before the variable. Okay? I mean, in the final part over there. Now, how do I show y times y? Angela?
you put y squared,
Y squared. And how do I show y times 3? Yes.
3y.
3y. And there's our final answer. Okay, next one. Okay, Lawson.
Okay, so I got 9 times x.
I always keep it in order, please.
Okay.
Let's do it in order.
Okay then. Let's see here. So x times 2 then.
X times 2x.
X times 2x, yes.
So I have x times 2x.
And
Keep
then-
going.
And then I got minus 9 times x.
Or x times 9. Perfect. So 9 times x stays like 9x with that minus sign. The first one in red, how am I going to write that? I always put the big number first. Jasmine?
2x squared.
Perfect. And that is your answer. I bet that was hard for a lot of people. Okay, next one. Piper.
Number 4.
Yep.
Okay, first you multiply 7 times 8, and then 7 times negative x.
Okay.
And you get 56 minus 7x.
Perfect. Okay, how about with variables? Can we do that? It's no different, same process. X times A is what? X times A is
ax.
AX. Put it in alpha order. Okay? My thing just died. All right, so now we're going to check our work. So when I'm multiplying x times a plus b plus c, I'm going to multiply x times a plus x times b plus x times c. And we usually put these in alpha order if there's more than one variable. ax plus bx plus cx. Last problem. 4 times 3 minus 4 times m minus 4 times k. So that gives us 12 times 4 minus 4m minus 4k. Pause the recording if you need to check your answers. Okay, if I have a geometric model for the distributive property, what that means is we take a rectangle, break it up into squares. So let's just say I've got this side of the rectangle is 5 units and this is 2. So altogether that makes a total of 7. I can break that up into 5 units by 2 units. And figure out 4 times 5 is, I can do 4 times 5 is 20. So we're doing our area is equal to length times width. So if I'm doing my width times length, they're interchangeable. As a whole, I'm doing the 5 plus 2, and that's 4 times 7. As two parts, I can take the measure of 4 times the measure of 5, and that makes 20. And the other area is the measure of 4 times the measure of 2, and that makes 8. No matter what you do, using order of operations or using the distributive property, we'll still get the same answer. 4 times 7, let's go back. Okay, 4 times 7 is equal to 28, and 4 times 5, simplify right underneath, is equal to 20 plus 8. They both make 28. Okay, so let's take the numbers away and let's find the area of this rectangle in terms of x and y and z. So I can do it in two ways again. As a whole, we're doing x. Why don't you try and do this one? Pause the recording. Now check your work. As a whole, we're doing x times the quantity of y plus z. That makes the length. As two parts, we're doing x times y, the area of x times y, plus the area of x times z. And when I simplify, I'll get the same amount. X times y makes xy plus xz, and this becomes xy plus xz. We're done. Do not simplify this. You cannot combine those terms. We'll talk more about that later. All right, now take a minute, pause the recording, and I'd like you to do 1 through 10. Now check your work. 3 times x plus 7 becomes 3x plus 21. 2 times a minus 4 becomes 2a minus 8. Now, if you have a negative, you're also taking that negative and multiplying it in. Negative 7 times 8 becomes negative 56. And negative 7 times negative m becomes positive 7m. A negative times a negative makes a positive. 12, number 4 is 12 minus 3a. Number 5, it doesn't matter if it's on the back end, it's still getting multiplied by everything inside the parenthesis. So it becomes 15 minus 5k. Number 6, xa, ax plus mx. Number 7, negative 12 plus 4r. Number 8, think of that like it's a negative. Think of that like it's a negative 1. Negative 1 times x and negative 1 times negative 8. That becomes negative x plus 8. Negative 2m plus 3. And number 10 is 18. Okay, again, we're just going backwards, but it's the same thing. It still means 3 times everything in the parenthesis. So I'm doing 3 times 2, negative 2y makes negative 6y. And 3 times 6 is positive 18. Okay, so we get 18 minus 6y. And that's the lesson on distributing.